Students, good morning. Really, I am so happy to see you once again through this CETEL YouTube channel. Today's class is a brief discussion on reversible and irreversible process. Before entering into this title, my first question is, what is mean by a process? How can you define the process? Say for example, have a cup of coffee. Have a cup of coffee. Now the coffee is too hot, unable to drink. Moreover, there is no sugar in this coffee. Pour 1 cube of ice into this coffee. A cube of ice is added to the coffee. What will happen? Coffee is a pot. Coffee is a pot. Sugar cube is a pot. So, a change in state of the system between the parts of a change of state between the part of the system. System means coffee with the sugar cube. This is the system. System is nothing but coffee along with the sugar cube. A change in state between the parts of the system. A change in state. A change in state between the parts of the system. Parts of the system. First definition. Now the coffee is too hot. Say for example 60 degrees Celsius. The surrounding atmosphere is more or less 30 degrees Celsius. Heat gets exchanged from system to surrounding. This is atmosphere. Heat gets exchanged from system to its surrounding. So, a change of state between system and surrounding. A change of state between system and its surrounding. I think now you are very clear. A process is nothing but a change of state between the parts of the system or a change of state between system and surrounding. Okay, this is the process. Why process occurs? Here the concentration of sugar is more. Here concentration is less. So difference in concentration tends to dissolve this sugar cube. So difference in concentration is the driving force. Why heat gets exchanged from system to surrounding? System temperature is too high when compared to surrounding temperature. Hence, there is a transfer of heat from system to surrounding. What I am trying to say is, driving force is must for a process. A process occurs when there is an existence of driving force. Driving force. Clear? Right. What about the magnitude of driving force? This is 60 degrees Celsius, this is 30 degrees Celsius. The difference becomes 30. So it is a finite value. It is a finite value. Say for example, the system temperature is 30.1. The surrounding temperature is 29.9. The driving force is infinitesimally small. Infinitesimally small. So driving force, one is finite value, another one is infinitesimally. Infinitesimally small. Clear? When the driving force is finite, the process is irreversible. Irreversible. Based on the driving force, when the magnitude of driving force is finite, the process becomes irreversible. When the driving force is infinitesimally small in magnitude, then the process becomes reversible process. Reversible process. Clear? First, let us see what is meant by irreversible process. Then we will discuss about the reversible process. Irreversible process. Irreversible process. Say for example, all spontaneous process are irreversible. All spontaneous process are reversible. Point 1. All spontaneous process are irreversible. Clear? That means naturally occurring process. All naturally occurring process are irreversible. They are accompanied by degradation of energy. Degradation of energy. Second point. These process will not be come back to its original state. These process will not be brought back into its original state or initial state. Original state or initial state without the use of external work or energy. External work or energy. Say for example, now the coffee is able to drink. Its temperature in the level of potable condition. Now my intention is again this liberated heat should be added to the system. Is it possible? It will not be possible without use of any mechanism. So irreversible process. All spontaneous processes are irreversible. They are accompanied by degradation of energy. These processes will not be brought back to original state or initial state without the use of external work or external energy. Point number 3. Point number 4. If the system undergoing an irreversible process, listen, if the system undergoing an irreversible process were to be brought back to into original condition, were to be brought back to its initial state, the surrounding would have to undergo some changes. The surrounding would have to undergo some changes. Listen this word, some changes. Either through heat interaction or through work interaction. Either through heat interaction or through work interaction. Clear? If a system undergoing an irreversible process were to be brought back to into original condition or original state, the surrounding should undergo some changes either through heat interaction or through energy interaction or work interaction. Clear? Right. Coming to the point of changes. If the changes remains in the system, point number 1, if the changes remains in the surrounding, or if the changes remains, if the changes remains in the system itself, then the process is called as irreversible process. Changes remains in the surrounding or changes remains in the system itself. The process is called as irreversible process. The process is called as irreversible process. Clear? What are the examples for irreversible process? First example, transfer of heat from hot body to cold body. Transfer of heat from hot body to cold body. Clear? First example. Second example, mixing of two pure gases. Mixing of two pure gases. Second one is diffusion of, third one, diffusion of solute from concentrated solution to a diluted one. Clear? Another one is rusting of iron. More number of examples. Rusting of iron in presence of oxygen. Clear? All spontaneous processes are irreversible. These are all the some examples for irreversible process. Clear? Okay. Shall we move on to the reversible process? What is going to be a reversible process? Reversible process. Before entering into this discussion, let us have a glass with water. A glass with water. It contains some amount of water. Can any one of you explain when the water gets evaporated? What is the criteria for evaporation? Oh, this is liquid water. Let me explain. This is liquid water. Over and above there is a atmosphere. This is called as atmosphere. In atmosphere, oxygen, nitrogen, helium, xenon, inert, dust, along with water vapor. What you call the moisture? Moisture or water vapor. Clear? Listen. The liquid water will always tends to escape into atmosphere. This liquid water will always tends to escape to the atmosphere. Hence, it produces some amount of force against atmosphere. Force per unit area is called as pressure. Pressure exerted by the liquid water is called as vapor pressure. Right, clear? Right. Pressure, similarly, the water vapor present in the atmosphere, this is also produce some force against atmosphere. That force is called as pressure. Pressure exerted by water vapor is called as partial pressure. Pressure exerted by the water vapor is called as partial pressure. Pressure exerted by water vapor is called as partial pressure. Pressure exerted by the liquid water is called as vapor pressure. Listen, when partial pressure is less than that of vapor pressure, notation for vapor pressure capital P, notation for partial pressure is small p. When partial pressure is less than that of vapor pressure, partial pressure of water vapor is less than that of vapor pressure of liquid water, then the water will evaporate. Clear? First condition. When the partial pressure is greater than that of vapor pressure, the vapor will condense. When partial pressure is equal to vapor pressure, the system is under equilibrium condition at a given temperature. The system is under equilibrium condition at the given temperature. Given temperature. Okay. Let us have this system in a piston cylinder arrangement. In a piston cylinder arrangement. This is the cylinder. Clear? It contains some amount of liquid water over and above certain amount of water vapor. Above that there is a piston. Frictionless piston. Subject to the condition frictionless piston. Clear? Okay. Now the partial pressure is exactly equal to vapor pressure. The force, the external force on the piston, acting on the piston. The external force acting on the piston is kept equal. The external force acting on the piston is kept equal to the force by vapor pressure of liquid water. Clear? This is the condition. This is the example. A frictionless piston is there. The external force through piston or external force acting on the piston is kept equal by the force of vapor pressure of the liquid water. Just listen. I am going to increase the pressure. By increasing this external pressure by an infinitesimally small amount, increasing pressure infinitesimally small amount. What will happen? Certain amount of vapor will condense. Certain amount of water vapor will condense. Clear? Right. Similarly, I am going to decrease the pressure. That means lifting the piston. I am going to decrease the pressure by an infinitesimally small amount. Decreasing the pressure. Infinitesimally small amount. What will happen? The liquid water will evaporate. Now you are very clear. The force acted on the piston. Similarly, force removed from the piston. That means driving force and opposing force are exactly balanced. Driving force and opposing force are exactly balanced. Driving force and opposing force are exactly balanced. The process is called as reversible process. You please mind in a small information the difference between driving force and opposing force. Difference between driving force and opposing force are infinitesimally very small. It cannot be differentiated, or it is less than that of the differential amount. It takes quite long time to attain the equilibrium condition. What I am trying to say is, reversible process is a very slow process. We the engineers wish to finish the process within a finite time. Reversible process will not be possible. Clear? This is the brief information regarding reversible process and irreversible process. Thank you. Romba thanks Ratha.